Okay, this is day 9 video, which is for Monday, April 6th. And today we're going to start on 11.3, which is going to solve radical equations. So all a radical equation is an equation that contains a radical. So they're going to look something like this. So first thing I want to do when I solve a radical equation is isolate the radical. Oh, if I had a plus 2 out here, I would just subtract 2 from both sides. We could actually go ahead and make that. So I'm going to isolate the radical. Here's my radical. I'm going to treat that just like my variable. So I subtract 2 from both sides. That's going to be 8 equals 2 times the square root of x. Continuing to isolate the radical, I'm going to take and divide both sides by what it's multiplied by. So I'm going to divide both sides by 2. So 4 is equal to the square root of x. Now notice, I just have the square root of x. So my step 1 is done here. The radical is isolated. Then I'm going to remove the radical by doing the inverse operation, just like I removed the 2 from the being multiplied by the square root of x by the inverse operation, which is division. The inverse operation of squaring, or doing the square root, is squaring. So I'm going to remove the radical by squaring both sides, or I could say by raising both sides to the proper power. Now, why would I say that? Because if I were solving an equation that had a cube root, then the proper power would be to the third power. So here I'm just going to square both sides of this equation. 16 is equal to x. Okay. Very important. This is not an option. It's not a suggestion. You must check your answers. So we're going to check solutions for what we're going to call extraneous solutions. Which are solutions that solve this equation after the radical's gone. Here we just got one answer. Sometimes we're going to have a bigger equation there, but do not solve the original equation, and they're called extraneous solutions. And we get that problem sometimes when we do these problems because we're squaring both sides of the equation. All right, so my original equation was 10 is equal to 2 times the square root of 16 plus 2. Well, we know the square root of 16 is 4, so 2 times 4 plus 2, that's going to be 8 plus 2. So in fact, that does equal 10, so it checks out. Now, you don't necessarily have to show me the check. If it's difficult, and sometimes they do get a little more difficult, you might want to jot it down. All I need to see is either a check through the answer, or if this came out to be x equals 5, and then 5 would not make that a solution, you put an x through it. All right, so I don't have to see the entire solution, or check rather. Okay. A couple more examples. Now notice this equation has 2 radicals, but it's simply one radical equaling another radical, so I can't isolate anything. They are isolated. So what I'm going to do is I'm going to go ahead and, at this point, jump right to step 2 and raise both sides to the proper power, which is going to be squaring them. And then my equation is 3x minus 5 equals x over 2. I know it's a fraction. Oh no. All you got to do is clear the equation of fractions by multiplying both sides of the entire thing by the least common denominator. So I'm going to distribute that 2 over every term. Gives me 6x minus 10 is equal to x. So I'm going to solve this for x. I'm going to subtract an x from both sides. This gives me 5x. And add the 10 over to the right side. And x is equal to 2. Well, let's check that. If I put a 2 in the left-hand side, 3 times 2 is 6. 6 minus 5 is 1. So I get the square root of 1 equals 2 divided by 2 is the square root of 1. So 1 equals 1. And yes, it checks. Like I said, you can show a little bit. You don't have to show anything, but you must put a check there. If you don't put a check, then it's going to be wrong. And if you don't check it and it doesn't check and you put a check, then it's doubly wrong. So make sure that you do your proper check for your equation, please. Okay, here's a third example for you. I'm going to go through my steps here. I'm going to isolate the radical. Well, it already is isolated, so I don't have to do any addition, subtraction, or multiplication. But now when I square both sides, I'm going to get a quadratic equation. So x squared is equal to 6 plus x. The squaring and the square root simply undo each other. All right, so anytime I have a quadratic equation, I'm going to set it equal to 0. So I'm going to subtract x from both sides, and I'm going to subtract 6 from both sides. Once I have set equal to 0, I'm going to factor it, set each factor equal to 0. And now we're going to have two possible solutions for this equation, and that can happen. They both can be good solutions. None of them can be a solution, or one of them can be a solution. And if you don't get a solution, you simply write no solution. So the factors of 6 that give me a difference of 1. So I'm going to put a 2 here and a 3 here. It needs to be a negative 1. So there's minus 3 and plus 1. So my two possible solutions are x is equal to negative 2 and x is equal to positive 3. Now I'm either going to put a check or an x through both of these. So let's see here. We're going to check this. The square root of 6 minus 2 is supposed to equal negative 2. Well, that's the square root of 4 equals, I don't have to continue because when I take the square root of anything, it's going to be positive. So that does not give me a solution. So if I put a 3 in here, that's going to be 6 plus 3 is equal to 3. So that's square root of 9, which is 3, which does equal 3. So there is a good solution. So sometimes some can check, one will check, or none will check. All right, check Google Classroom for your practice problems, and please get caught up on all those old problems and ask me any questions. I can put solutions on Google Classroom, or I can do examples here for you. Have a great day.